Hello dear students, welcome to Tejamaya YouTube channel. In this video, I am going to solve the numerical questions from the chapter Wave Optics. Usually, you could see a question which comes for numericals, especially for 5 mark from the chapter Wave Optics, that too particularly from a topic called Young's double slit experiment. If you have already learned this particular concept, it will be very easy for you to understand, and for those who have not attended the class on the topic Young's double slit experiment, today I am going to give a brief explanation on that and I am going to solve the numericals on that particular topic. So usually they ask questions on calculating the wavelength of light that we use here and calculating the distance between the slits. Then they could ask you to calculate the distance between the slits and the screen. Also, they will ask you to find out the fringe width and distance of the fringe. It could be a bright fringe or dark fringe. So without wasting time, I am going to explain you the Young's double slit experiment in few minutes. Then I will solve all previous year questions which has appeared in the previous year question papers. Okay dear students. So here I have drawn the diagram of demonstration of Young's double slit experiment. So usually we take a monochromatic source of light here, or we can use white light also. Usually take monochromatic light. So this is the source of light of particular wavelength. Let us consider lambda. And here we have a slit or two slits in a screen. Okay. So this is the slit 1. This is slit 2. So what is slit? Slit is nothing but a small narrow opening. Through that light can pass through. Here also light can pass through. Here also light can pass through. So these two sources or slits act as sources. Okay, and those two sources are called coherent sources. What is the meaning of coherent source? Very important question for 1 mark or 2 mark. Okay, so here the waves which are coming out of slit 1 and slit 2 will be having the same wavelength, same phase or phase difference. Okay, so that's why these two slits are considered as coherent sources. So when the light waves which are coming from coherent sources interfere each other, they form or produce interference fringes on the screen. Here we have screen and here we can see the fringes formed on the screen. So one is bright and dark, bright, dark, bright, dark, bright, dark, bright, dark, like that. So alternative bright and dark of equal intensity with equal width. See, distance from each one fringe to another fringe is equal. So distance is equal, intensity is equal, size is equal. That too, this happens in case of interference. Okay, so do remember that, dear students. So these are all called fringes. What they are called? Fringes. So fringes, what they are? What is the meaning of fringes? Nothing but the light waves, these two waves combine together and form spots, bright or dark spots. You can see the shared image of the intensity pattern that happens especially in case of actual demonstration, practical demonstration. So look at the screen now. Now here, when these two light waves join together, so they form intensity pattern and they are called fringes. So the distance between one fringe to the consecutive fringe is called fringe width. Okay, sir, you are considering only the bright spots. What about dark spot? There are also fringes? Yes. See, the black color one is considered as bright spot. The next one is dark spot, means there will be no light there. Next bright, there will be light, no light. There is light, no light. There is light, no light. Why it happens? It happens because of interference. Light plus light, more light, means both the lights join together and form more light here, means intensity will be more. When light joins with light, no light, that is called destructive interference. So that there will be no light here. There will be light here, light spot, no light, there is light, no light, there is no light, no light. There will be light spot formed on the screen. So especially here we are concentrating on numericals. So they will ask you to calculate the wavelength of light. They will ask you to calculate the distance between the slits. They will ask you to calculate the distance between the slits and the screen. Also, they will ask you to calculate the fringe width. That's it. One more is there. They will ask you to calculate the distance of the nth bright fringe or nth dark fringe. Okay. So, if I consider for reference, this is the central bright fringe. What is this? For reference, we will consider central bright fringe. Central bright fringe. Then, what is the distance of first bright fringe? Beta. What is the distance of second bright fringe? Beta plus beta, 2 beta. Distance of third bright fringe? 3 beta. Distance of nth bright fringe? N beta. Means distance of nth bright fringe is given by n beta. Then again, what is the formula for beta? How to calculate beta value? It is calculated by using the formula lambda d by small d. Dear students, do remember. So beta is equal to lambda d by small d. And if we substitute that here, we can find out the distance of nth bright fringe. Sir, how to calculate the distance of first dark fringe from the central bright fringe? First dark fringe from the central bright fringe, third one, fourth one, fifth one, or second one, like that. How to calculate that? So there is one more formula for that. That is xn is equal to 2n plus 1 lambda d by small d into 2. So 2n plus 1 lambda d by 2d. This is the distance of the nth dark fringe. I will write these three formulas separately. Okay, as of now, do understand what it is. So here n means nth bright fringe, means if there is first bright fringe, n value is 1. Second bright fringe, n value is 2. Third bright fringe, n value is 3. Like that it goes. But in case of this, it is not the same. If they ask you to find out the distance of first bright fringe, you have to take n value as 0 for first, sorry, not bright fringe, it is dark fringe. First dark fringe, n value is 0. So n value is 1 for second dark fringe. For second one, you have to consider this. N value is 2 for third dark fringe. So for bright fringe, means constructive difference, you have to take n value as it is. Calculate the distance of nth bright fringe means n value is n. Fifth bright fringe means n value is 5. Sixth bright fringe means n value is 6. But when it comes to the concept of dark fringe, you have to substitute one value less to the n. Means if they ask you to find out the fourth dark fringe, you have to substitute n value 3. 10th dark fringe, n value 9. 7th dark fringe, n value 8, like that. So keeping that in mind, okay, let me write all the formula again on the screen. Okay, dear students, now I have written all the formulae which are required to solve the numericals on the concept Young's double slit experiment here. So the fringe width is calculated. It could be between the two bright fringes or two dark fringes. So the formula is same. Beta is equal to lambda d by d, where lambda is the wavelength of light, capital D is the separation between slits and the screen, small d is slit separation. What is the separation between two slits? Then the distance of nth bright fringe is given by xn is equal to n lambda d by d. So if you want to calculate distance of first bright fringe, n value is equal to 1. Second bright fringe, n value is equal to 2. Third bright fringe, n value is equal to 3. So on. There is no confusion in that, ambiguity in that. But here, if you come to calculate the distance of nth dark fringe, you have to calculate n value as n minus 1. Means, if you want to calculate the distance of first dark fringe, n value is 0. Second dark fringe, n value is 1. Third dark fringe, n value is 2. 10th dark fringe, n value is 9. Seventh dot finch n value is 6, like that. So don't get confusion here, because this is very important concept that you could pakka get one numerical 5-mark questions. That too, this time what is that, blueprint has fixed that they will give one 5-mark pakka question on this particular topic. Okay, dear students, so let us take up solving first question, which was given in the year July 2016 Karnataka board examination. Okay, so first of all, let me read out the question. In Young's double slit experiment, while using a source of wavelength 4500 angstrom, the fringe width obtained is 5 mm, means millimeter. If the distance between the screen and the plane of the slits is reduced to half, what should be the wavelength of light required to get fringes of width 4 mm? Okay. Now let us try to understand what is the real meaning of this particular question. Okay. So here they have given the question on Young's double slit experiment only. There is no doubt in that. So here Young's double slit experiment means there will be two slits which are separated by small distance, and these slits are at a distance capital D from the screen. Okay, this is the distance between screen and the slits. Dear students, when they use wavelength of 4500 angstrom, the fringe width obtained is somewhere around 5 millimeter. Millimeter means 10 to the power minus 3 meter. Angstrom is 10 to the power minus 10 meter. You need to convert it into what is that? Meters. Okay, it is required, but let me keep it like that only. Now, capital D dash is equal to D by 2 means if the distance between screen and slits is reduced to half, this is the D dash. D dash is half of capital D. If it is moved towards the slits through a distance of D by 2, then what should be the wavelength of light, new wavelength of light, to get a fringe width of, beta dash, this is the beta dash of 4 mm. Simple, make use of this formula. How sir? Let me take. Beta is equal to lambda d by d. This is for first case. Here we have two cases, because here lambda is changing, beta is changing, capital D is changing, but there is no change in the value of small d. Slit separation is not changing. Let me keep it like that. Second case is what? Beta dash is equal to lambda is changing, capital D is changing, and small d is not changing. Okay, if I divide these two, so dd will cancel out, remaining terms will be there. I can substitute the value and find the answer. Okay, let me take like this: beta dash divided by d is equal to, beta is equal to, what is that? Lambda dash d dash divided by small d whole divided by lambda d divided by small d. Here small d will cancel out, then that is equal to lambda dash. What is d dash? D dash is half of d divided by lambda d. Again dd will cancel out. Okay, so that we will get lambda dash divided by 2 lambda. So solving this, we want to calculate lambda dash. Okay, what should be the change in wavelength? So that we need to new wavelength to get this fringe width. So 2 lambda will be multiplied this side. So we will get lambda dash is equal to beta dash divided by beta into 2 lambda. Okay, so first of all, dear students, if you want to calculate a numerical perfectly, you should know the basic mathematics. Second thing, the language to understand the question. Okay, now lambda dash is equal to, what is beta dash? 4 mm, beta 5 mm into 2 into, what about lambda? 4500 angstrom. Okay, here mm will cancel out, 5 nines are, so we'll be having 900 here, 9 2s 18, 18 4s are 72, so lambda dash is equal to 7200 angstrom. So this should be the wavelength of light used to get new fringe width of 4 mm by changing the capital D value to D by 2. Okay. So this is all about this question. Hope you have understood this. So you can pause the video and take the note, and after that you can watch the second question. So now I am going to solve the second question. That is, in Young's double slit experiment, the fringes of certain width are produced on the screen, kept at a certain distance from the slits. When the screen is moved away from the slits by 0.1 meter, the fringe width increases by 60 micrometer. The separation between the slits is 1 mm. Calculate the wavelength of light used. Okay, so first of all, let me write the data on the screen. Okay, dear students. So here they have given the data like this. So this is from the concept Young's double slit experiment, where I have written the basic formula for fringe width, that is beta is equal to lambda d by d. So they have given the data like this. Initially, for a particular value of d, capital D and lambda, they are getting fringe width beta. But if they change capital D by an amount 0.1 meter, means capital D plus 0.1 meter, so the beta is changing by an amount 60 micrometer to the actual beta. Okay, so beta plus 60 micrometer is the new fringe width, and small d is given 1 millimeter. Now they are asking us to calculate the lambda, that is the wavelength of light actually used. Okay, here if I take beta dash, then it will be like lambda d dash by small d. Okay, so why I have not written lambda dash? Because wavelength is not changing, small d is not changing, but d dash is changing and beta dash is changing, fringe width is changing. Now if I write like this, beta dash minus beta is equal to this one minus this one, lambda d dash by small d minus lambda d by small d. So beta dash minus beta. So beta dash is beta plus 60 micrometer minus beta is equal to lambda by small d into d dash minus d. Can I write like that? Yes, of course I can write. So now beta will cancel out. 60 micrometer is equal to lambda that we need to calculate divided by small d is 1 mm. Let me write that here, 1 mm into d dash is how much? D plus 0.1 meter. So minus capital D. Here again capital D will cancel out. Now I need to calculate lambda. So lambda is equal to 1 mm will come this side. So 60 micrometer into 1 mm divided by 0.1 will come down, 0.1 meter. Okay, so if you convert these units into meter, 60 into 10 to the power minus 6 micrometer into 1 mm means 10 to the power minus 3 meter divided by 0.1, you will get meter will cancel out. So you will be having 60 divided by 0.1 is 600 into 10 to the power minus 9 meter, nothing but 600 nanometer. Okay.